The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Thank you for joining today's EAC webinar. This is Cassie Stumo. I'm the marketing specialist here at EAC. We'll start off today by telling you who we are, and then PTC's technical specialist, Colleen Garrigan, will be presenting on everything Mathcad. Everyone will get a recording of the session pending any technical difficulties. Use the chat function to ask questions, and we will answer them after the presentation. I will pass things over to Justin to give us the EAC introduction.
Good morning. Hope everyone is doing well. I will start off with a quick introduction to EAC. Our mission is to transform the way companies design, manufacture, connect to, and service their products. We are proud to be the #1 solutions provider for PTC in the country, offering our customers everything they need for product development to stay ahead of the game with advancements in the latest technology. We offer service lifecycle management software, which helps you create and manage service documentation, product data management software like Windchill, ThingWorx Navigate, and our customizable EAC productivity apps, which helps you to manage internal product data. We implement the Internet of Things and augmented reality into business strategies to jumpstart initiatives around digital transformation and connecting all things in your company. We assist with design and engineering projects like FEA, simulation, reverse engineering, and proof of concepts for our customers. And we offer webinars and PTC certified training courses for continuous learning. We are also a commercial reseller for Formlabs, offering their latest products in additive manufacturing, the Form 3, an affordable desktop 3D printer, and for larger industrial prints, the Form 3L. So keep us in mind. We really have a variety of tools to help your organization save time and money throughout the product development process. Today, though, Colleen will show us an overview of PTC Mathcad. Colleen, take it away.
Great. Thank you. So today we're going to be talking about PTC Mathcad Prime. So just to give us a just general picture here to start off with, Mathcad is a general engineering notebook that's going to help you perform calculations and document your design intent. So it's a software specifically made for documenting the engineering process. Some challenges that we see companies have and that we think Mathcad can really solve is a lack of standardization. So they could have really important engineering documentation scattered across many different forms, like what we see in this picture here. Paper and pencil, you could have people just jotting down ideas. You could have it on spreadsheets like Excel, different documents like Word or any other engineering documents that you have on your computer, and also reference manuals. And when it's scattered like this, it's very hard to go ahead and share and reuse all of this hard work that your engineers are putting in. When you have it scattered and not a very good and not a way to check all of that work, it's hard to catch any errors that happen. One example of this is the Mars robot in 1999 that NASA sent up to try to monitor Mars weather. So what happens when they sent it up is that they were using some vendor's calculations, and the vendor was using a different unit of force than NASA was, and that unit never got converted. So when the Mars robot made it all the way to Mars atmosphere, it couldn't calculate thrust right, and it ended up burning in the atmosphere. So it was $1 million mistake just on a simple air conversion. So our solution here is PTC Mathcad Prime. So it's going to help you fix the errors. It's going to tell you when there is an error, and then help you analyze, solve, document, and share any of your engineering notations, your design intents, your calculations. It's going to have that all in one place, so you can easily send off just one document to anyone else who needs to reuse your information. So again, it is a digital engineering notebook that's meant to document your design intent, from your calculations to just words, but saying why you made a decision. So again, software for that engineering process. Okay. So you can import drawings, you can import Excel spreadsheets, perform calculations, create plots. So it has that strong math engine behind it that's going to help you do any calculations that you need. So we see these pictures here. It's just saying that it's something that someone could sit down and read and not have to learn a whole nother coding language in order to understand. So it's going to combine the ease and familiarity of an engineering notebook. You know, it just looks like a grid paper that you'd have on your desk, but it's going to combine that with that powerful math engine so it can do those calculations, make those grids for you whenever you need them. So it looks just like a regular document, except, you know, much neater, you know, than me trying to sit here and write out anything in a nice structured format. So a little bit more about the specific capabilities of Mathcad is it's an intuitive, easy to use whiteboard interface. So there's no cells to keep track of. Everything is going to be visible for you on this page. It has natural math notation. You're just going to type in x plus y equals and it solves. So just again, you're not learning a whole nother coding language in order to use this. You could send off your documents to any other engineer, even if you know different coding languages and there's no overlap, you would still be able to understand what's on that Mathcad page because it just looks like regular math. And like that NASA story I talked about earlier, you won't have to worry about if you get vendor data. If you import that into your Mathcad workbook, it'll make sure that those units match up with the ones you are using. So it's going to manage them automatically, save you a whole bunch of headache trying to dig down and figure out what units we're using over here versus mine. It'll fix that all for you. It's also going to be self-documenting. So you could start it off as scratch paper. Let's figure out what's going to be the optimal dimension for this piston or anything that you're calculating. And while you're going through optimizing it, it can turn into that final documentation to send up the chain or to different vendors or for anyone else to see. A little bit more about the capabilities is that it's what you see is what you get. So on this page, we see this grid, we see the graph, we see the picture. When you print it, it's going to look exactly like that. The formatting won't change a bunch and everything will still be on that page. You also have a huge function library of math notation, solving, data analytics, statistics. So you don't have to reteach or define functions for Mathcad. It's already built into it. You can also have huge capabilities for building plots like XY plots, polar, contour, or 3D plots. So they're live plots based on the data that's within your workbook. So it's going to be updating every time you make a change in front of it. You can stretch it out, any plots you make, change what the axis is, change the units. So there's a lot of different ways that you can display your data and really get your point across to whoever's looking at this. Mathcad is also integrated with Creo Parametric. So it helps you document your design intent if you're working in Creo and you want a notebook attached to it. Mathcad can be permanently attached to this Creo Parametric file, and when you send that off, you can send Mathcad with it and people will be able to read exactly why you made the decisions that you did and be able to see your process of how you made a decision. So that means somebody else, when they're doing a similar model or the next round, will be able to follow your same process without rethinking it by themselves. So it really communicates. It has analyst-driven design because you're taking variables, parameters, calculations from Creo. So you could be working out a model, making sure it looks okay. Push those values into Mathcad. Do some optimization work, find what dimensions are going to work best, and then push those values back into Creo. So it's a circle here, and you can do that communication back and forth. So you're going to verify your design decisions by having that connection and making sure that everything you're picking is going to work out in the end. So now I'm going to move into a quick demonstration here of Mathcad, and then we will wrap it up with some more slides. Okay, so we're starting off here on a very empty title page. And we see that it looks like a grid here, but if I move into one that I've already started, so it's going to have a lot of that base work done for me, and we're just going to go through and edit it to fit our needs better. So we have our title page here at the beginning, very simple. It looks like a Word document. We're going to format the text using that very familiar ribbon that's in Word, Excel, etc. So we're just going to bold our text, make it bigger, and make sure that it's the right color. We can also take off those grid lines if we'd rather have it be a blank background. Moving on to our next page, we're going to talk about beam deflection. So we start off with a picture here, a nice diagram showing us what we're going to be talking about, our variables D and B. Now, when you saw that I double-clicked on that diagram, it brought us into PowerPoint. So that is a huge new feature of Mathcad Prime 4. So what it allowed is it's an OLE container that allows us to double-click in the Mathcad space, and it'll automatically open up PowerPoint, Excel, Word, whatever you're making these drawings in, or whatever you have a spreadsheet in. You can automatically open it up, and you can make any edits and changes that you want, like we're going to do here in PowerPoint, and those edits can be pushed straight back into Mathcad. This means you won't be searching through your computer to find, oh my gosh, where is that PowerPoint file that I made this drawing in. It's automatically attached to Mathcad. You just double click it and it opens up for you. So we'll just give these middle lines a color here, close out of it, and Mathcad will automatically update. So that's an embedded object that we have there. We can do PDFs, Excels, PowerPoints, even Microsoft Paint. So we double click and that embedded contact pops up and we can make changes to it. So we're going to start doing some natural math notation right here, defining those variables that diagram is showing with B and D, and then doing a calculation with those variables. So let's say I accidentally type in H here instead of D, and let's see how Mathcad handles it. It ends up giving us all of these units at the end, and we know that we haven't plugged in units yet. So we can go back, look, do that, check, I don't think that's right. See that we accidentally typed in H. Now when I ask Mathcad what H is, it's Planck's constant, and it'll pop it up there for us. We'll know that that is not what I meant to type in. So Mathcad has all of these variables and functions already built into it to help us do any work we need, so we don't have to reteach it anything. And then all I have to do is change that back into D, and I will update for me. Okay. So units are also very important. That's that story we talked about earlier, where you want to make sure everything's in a compatible unit and everything is converted correctly. So I just add some units on B and D there, centimeters. I will update for me to change it to meters instead there. If we want to keep that in centimeters or change those units, I just change that M to a CM, and again, it's going to update. So it's going to keep track of units, so you won't have to, saving you a whole bunch of time, and also it won't let any simple mistakes from units happen. Say someone accidentally forgot what B stood for and tried to add centimeters to seconds. Mathcad would stop you and say, I don't think we can add these units together, allowing any errors to not go through the cracks like that. Next, what we're going to talk about is, so we had that connection to PowerPoint where we open up that diagram. We're going to do something similar with Excel here. So Mathcad has Excel features built straight into it. So it's extremely important if you want to reuse everything that you already have. So you don't want to have to retype in all those Excel values that you have, and you still want to be able to use Excel for its capabilities of a spreadsheet, but maybe combine that with Mathcad so you can see all of your functions all out in the open instead of hidden in a cell. So we don't have to throw away or retype any of our Excel. We're just going to grab the rows and columns that we'd like to use within our Mathcad workbook. So it's going to read the Excel sheet straight from there and pull it in whatever that data is. So I'm just going to ask Mathcad, what are those rows and columns? Maybe I realized, oops, I meant to grab the row above that, and we can go ahead and change that. Okay. So next, we're going to use that data in a calculation using matrix notation. So we're going to see what the value in that matrix would be in a different unit. And it's no programming. It's just like typing like you would on a piece of paper there. Next, we're going to look at this nice diagram again that we have on our right, and we're just going to define the variables right next to it. Again, you're having text all in with diagrams, with pictures, with Excel spreadsheets. You're combining that all together to have one place that you can send off to any other engineers, vendors, other employees that join. You can send this one document off to them instead of searching through everything, pencil and paper, Excel sheets, emails. You'll have it all on this one place. We go and do some calculations with those variables that we just set up. And what we're going to take a look at here is this is a feature that was improved with Mathcad Prime 4, which you can protect areas with passwords. That means you can hide them and make them so you cannot open those areas to any vendors or other employees you send it to, or you can make it so that they can't change anything you have within this protected area, just allowing you to have more control over your intellectual property. So we'll just give this a password here, and we are going to keep it expanded so you can still see it, but you have that option to collapse it so no one's even able to see the data you have within your protected area. So we're going to just do a quick calculations with those variables that we set up earlier, see what the deflection is at L/2. And the default, again, is it's going to output any of those units in meters. We can change that to millimeters very easily. Here is a different area that we have collapsed. It's just some more complicated derivation that we don't want people to get caught up in whenever they're reading this Mathcad workbook. So we can have all of this math. Again, Mathcad has that strong math engine to perform these calculations that you need, but it also has the capabilities to go ahead and hide this. So if you're sending it off to someone who you have that it needs approval from, they won't get caught up in that complicated math. They'll be able to see the big picture without having to go in the nitty-gritty there. So it's really going to have control of how you want the document to be viewed. Again, we can change those units very easily there. We're just going to scroll through some of these plots here, again, so that you have capabilities to do XY plots. We're going to go in a little bit more detail about that in a minute. So we earlier took a look at reading in an Excel document. Now we're going to take a look at that same way that we had the PowerPoint, where we opened it up and we're able to change the colors of our diagram. We're able to do the same thing in Excel. So we're having this chart being read straight into Mathcad, and we can double click on it and make any changes we'd like within Excel. So I'll go ahead and highlight the row headings there, bold all the text, and center it. Again, close it out, and it updated for me there. So again, not digging through my computer to find that. I just double click and it opens. So now I'm going to go in a little bit more detail about the new feature in Mathcad 5, Mathcad Prime 5, where you have full capability to go ahead and edit those XY charts that you make. So I double clicked on my XY chart, and I'm going to make some changes just to make it pop out more and really be able to understand the point I'm trying to get across with this graph. I'm going to give it a legend. I'm going to add in a background color so the chart area stands out more. I'm going to give it a title. So before, when you looked at this graph with just those 3 lines, you didn't know what it was trying to tell you. Now, if I give it a title, I add in a background color so it pops out. I can define the X and Y axis. So someone who looks at this will be able to understand what this graph is trying to tell them. So we'll just give it an XY, deflection and distance across the beam. I will change each of these lines just so they stand out more. So again, you have all of these formatting options within this one pop-up that comes up. So you're not searching through a whole bunch of formatting tabs. It's all in this one place. I can click through and edit my graph how I think it's going to look the best. So we'll just go ahead and format my last line here. Give that a title as well. And as you can already see, this graph looks so much better. We're able to understand that it's a deflection curve and what those two, the green and red lines, are highlighting for me here. We add in some vertical markers, really point out the position of maximum deflection. So taking a little bit look into the programming skills of Mathcad there. So it's going to help you, it can help you define the maximum deflection change as the load and position varies. So we can have a calculation and then do a scatter plot with it. We can also have a 3D plot. So you can use 3D plots to visualize a function with two variables or a 3D data set. So we're going to plant surfaces with mesh, curves in 3D space, or scattered data points. We can also give this a background color, and we can spin, pan, and zoom all within this 3D graph. So again, it's not a picture of something. It's alive that you can manipulate, zoom in, zoom out, do whatever you'd like to it. So we can just define the axes there. We have those three variables, formats. We can change any of these axes that we want to zoom in or out. And then we zoom in and out, spin it, and we can interrogate a smaller section if we'd like as well. Okay, so everything is fully documented, and now you have an engineering document that's ready to go. You can send this out, and someone would get the idea that you're trying to make very quickly. So you can use it to predict the design's behavior. You can use it as a connection with Creo to drive critical parameters and dimensions, double check that all of those are correct, and have it all in the one spot. Going back into my PowerPoint here. So I just wanted to talk a little bit. I did mention throughout the demo what's new in Mathcad 4 and 5, but just to highlight it out a bit. In Mathcad Prime 4, we had performance enhancements like document performance and plot performance. So you're able to plot more points with Mathcad 4, Mathcad Prime 4. Okay. We also had that contact protection, which we took a look at and made a password for that area that we didn't want anyone to just be able to open up and see. We can collapse any of those areas, protect our intellectual property. We also have huge capabilities to operate with other third-party apps like Word, PowerPoint, Excel, and we took a look at that when we would double-click and it would open up that file in PowerPoint or Excel. You can also copy and paste multiple regions into Word now. Mathcad also made it easier to put in equation breaks, fix some Windows 10 support, it included Windows 10 support, and then fix some bugs for you. A little bit more about that content protection. We did take a look at this in the demo, but I just really want to highlight this out because it gives you control of your information, of all that engineering work you put in. If you want to protect an area, if something is still in the works or patent protected, you can absolutely hide that area. And again, a huge new feature that was added is being able to have those OLE containers where you can double click and then edit that diagram, edit that chart within the program that you made it in without having to search through your computer for that file. And then Mathcad Prime 5 included that where we changed that XY chart from something we didn't understand what it was supposed to be telling us to that finished plot where we could take one look at it and know what the point of it was. That was the huge benefit of Mathcad Prime 5. So you can plot multiple y-axes on the same plot now. You can edit any aspect of the plot, titles, axes, and plot appearance. You can choose from dozens of fonts, styles, and text options. You can add grid lines if you'd like, or value markers to point out specific values. And then you can also insert plot and axis titles. We did go through all of this in the demo there, and we see from the beginning in my PowerPoint slides where we had that graph, we didn't know what the point was, to the end here where we're able to take one look and know what is this graph telling me. That's what Mathcad 5 gave the possibilities of. So just a couple slides to wrap up, just to kind of why is this important about Mathcad Prime here? It's going to prevent the loss of intellectual property and improve knowledge capture. Because you won't have everything scattered through emails, Excel sheets, different workbooks. It'll all be in that one spot where you can easily share it off and no one will have to redo all of the work. You can also optimize critical design and engineering processes by having that connection with the CAD tool to allow you to analyze, verify, and validate while you're going through that design process. can also improve your product quality. If you have that extra check to make sure all the units are compatible, not everything has been converted to the same one, it's going to help you make sure there's no uncertainty that you're meeting the design requirements. Can also speed up your time to market by having this tool that has a strong math engine, but also is documenting that you can easily send it off. You won't have to duplicate any of that. It's also going to improve compliance with regulations. So you can document how you got to that design, let everyone know why you made the decisions that you did. So again, it's going to allow for everything to all be in the same spot. You're going to be able to view every function, every value with Mathcad, and it's not going to be hidden away in a cell. And it's going to make sure that all those units are converted without having anyone do any of that nitpicky work. And again, be able to share it off to everyone with one sweep. And we also had those new graph capabilities, so we're able to compare data sets with ease. The data can be displayed quicker, and a plot can be suited for your specific needs. And you're just going to enhance the visualization of the data to make sure you get the point across to other people that need to understand your charts. Okay, so with that, we can open it up for questions. So again, we have this last line. You can visit EAC on their website there. So if you have any questions, we'll take a look at, you can post them in the chat and I can do my best to answer any questions you have.
Thank you so much for that presentation on Mathcad, Colleen. I don't see any questions in the queue right now, but please reach out if you do have any further questions. You will be getting that webinar replay later on today, so you can reply directly to that. Thanks again for joining, everyone, and have a great rest of your day.